So fractions are just a part of what we do. And so one of the things being able to work with is what's called converting numbers, simplifying, changing over depending on how you want to look at some things. So for instance, here with all of these, most of the time, or at least some of the time, the way we'd go about doing this is trying to figure out the largest number that's going to divide into both of these. Now, sometimes we can snap that off pretty quick. We might look at this and go, hey, I can divide each of those by 5. Divide 25 by 5, divide 40 by 5. I'm good. But what if it's something that's trickier? What if I'm just not feeling it at that time to try and figure out how this would work? We've got a little help. If I can get away from the glare. There we go. So anytime that you have got these in a form like this, or even in an improper form, with the calcs in here, with the calculators in here, you can punch this in the math button right there below alpha, that green one. If we hit math and enter twice, it'll do the fraction reducing for me. Now, is there still benefit in knowing how to do that on my own and challenging myself a bit? Yeah. You may not have a fancy calculator like this at some point, even though we've talked about the apps you can get on your phone these days to try and work. But I mean, it's still nice to be able to just type in a fraction. Hit that math button right below alpha and enter a couple of times and get there. But here's what I wanted to mention. So let's say sometime you're out and about somewhere or going along, and I don't have a calculator stuff, and I'm trying to do something like this for one reason or another. So let's say I run into 5. So what I might do, and what's reasonable as well, is I can say, okay, well, I know both of these divide by 2. So I just kind of play with it. And I'm like, okay. So I divide by 2, and I'm kind of looking again, and I'm like, well, wait a minute. I think I can divide those by 2 again. Sometimes we can just take little bites of a problem, piece by piece, and then I even look one more time, like, wait, I can divide each of those by 2. Now, would I rather just look at that and say, hey, those were both divisible by 8 at the very beginning to be done? Sure. But even if you take it in small pieces, you can get to where you need to be. So with those, that would be my suggestion to you. Math enter's nice when you have the option, but try to challenge yourself on a couple and be like, hey, what if I, just tried to see, can I divide a number into each and see if I can get there on my own? And I'll just mention it now while we're working our way down the page. This is going to be one of the Hardy infamous notes practice sheets where we do a few examples with the odds, and then the evens would be some of the ones you want to practice on. Now, do you need to do, 20 of these? Probably not. But at least 2 or 3 in each section just to kind of give yourself a little bit of practice play with those. Okay? Now, will they always be like this? Regular math class? Probably. Outside in the world? Probably not. So, improper to mixed. Now, why would I want to do this? Let's say especially since I'm kind of the foodie guy. If I'm doing measurements when I'm in the kitchen, I don't necessarily, and I don't think I'd see this very often with a recipe or something, but I'm not wanting to look at these in this improper fraction mode. I want to see a mixed number if it's greater than 1. It makes it easier for me to do totals and stuff. Now, here's our disadvantage. We're going to be like, uh-oh. Are there ways to get to improper in this calculator? Maybe. But I do, okay, 9/5 math, enter. Oh, crap, it's the same thing still. So, what are my options? Probably the most straightforward option is to do straight up 9 divided by 5. and be like, okay, 1.8. So now what good does that do me? We're going to take the whole number, the 1, and there's two ways I can tackle this. I can either take the decimal part now and do math enter enter. Okay. Or I could, when I get to that 1 whole, remind myself, okay, that 1 whole would be 5 out of 5. And if this is 9 out of 5 and that 1 represents 5, I got 4 left. So there's lots of ways you can do this. You can even do long division, but that's me showing my age that I like to do the long division thing as I'm going. Did an even, what the heck. I want to do one more this kind of way we're doing it. Then we'll see if we can get creative here. So again, just taking the number before the decimal. Now this gets a little more interesting. Ooh. I just saw something else we can try. Because I think, yeah, we're going to get in trouble sometimes with these decimals. Well, what if that happens? Oh, I got answered. This is good. Yes.
You can round it up because the 8 is over 5, same with the 7, so it'll be 0.8 instead of 0.7 repeating.
Okay, let's try that out. Now, I'm going to put that on a sticky note here for a minute. Because I think we're going to be really close, but I'm not sure. That 5 is scaring me, but let's see. Got another idea for you. We're going to put a little side note in here. So I look at this, and I'm going to say, okay, so 9 times 6 is 54. Okay, we've got that here. Now, if I take that 61 and I minus 54, that's 7. Because we were mentioning the other day when we first started, because Emily knocked this out of the park for us and said, hey, when we're kind of going back and forth here, we can multiply these two and then add the top. So here, I know I'm right, because 9 times 6 is 54, and then if I add 7, I get back to 61. So, if I get into a situation where I got the big long decimal and it's not being real nice, rounding works for us almost every time. This is the one time where that can get a little bit tricky for us. So let's try one more together. Then I'm going to freeze frame and have some of you guys try one here. Let's try this one. So 14 divided by 6. Okay, so we've got the 2. We know we're good there. So if we do that, math enter, enter, 7/3. That's not where I'm wanting to go, though. Yes, it's 2 over 6. Math enter, enter. Okay. That seems a little odd, too, because it's like, well, those don't match up. But let's dig a little deeper. If we try the same trick we did here, where we do 2 times 6 is 12. 14 minus 12 is 2. You're like, wait a minute. Hardy, you do something kooky? We did not do something kooky. So, yeah, 6 times 2 is 12. Plus 2 is 14. Now, you're like, but wait, why did I get a different answer then? Or did I? Are these kind of the same thing? Yeah. They're 2 6s just reduced to 1/3. So like if this was a problem you were working on in the practice or even on a quiz, okay, I might write something to the side to say, hey, you can still reduce this, but mathematically that still works. We just would like to try and get a little further. So there's some twists and turns when it comes to this part. It's a little different for sure, but I'd be happy with you going either way on that. So, I'm going to go freeze frame for a moment. Give 19 a go. There's one other one I think we're going to freeze frame here shortly. I will get some stuff done on the side here, so if somebody's checking this out later, freeze it instead of just checking out my answer. See if we come up with the same thing here shortly. You go straight to your outcome. 25 divided by 3, you're going to get 8.33333333. So we've got the 8, and I think probably, if you see the 0.33333333, we know it's 1/3, but that one actually works with the math enter, which is nice. But is that always going to work? Yes, maybe. Oh, nothing, just getting the stretch in. All right. One last one to play with in this section, then we'll reverse. This is the trickiest part of what we're playing with today here. So, okay. 20 over 7. All right, let's check this out. 20 divided by 7. All right, so I got the 2 part. Oh, dear. 0.857142. That's a lot of stuff to deal with. Math, enter.
You know, instead of writing it all out, just minus it.
Ooh, okay, I'm with you. That's an even faster way of doing it. I like that, too. I like this group. In the morning, you guys are sharp right off the bat and stuff. So it's not giving me my fraction part that I want here, though. So let's see here. So I got the 2. So 2 times 7 is 14. And 20 minus 14, we're just doing this minus what we got there, is 6. And I kind of start to continue to notice that pattern. That's going to help us in a minute with what we're doing next. When I look at this, I'm like, okay, 7 times 2 is 14 plus 6. So multiply and then add. And I get to that 20. And the reason I mention that is because when you get down to this last part, that's exactly what we're doing to get back to these numbers. We're just doing it in reverse. So all we're going to do here is we're going to multiply the 7 times 3, and then we're going to add the 2 to it. So 7 times 3 is 21, plus 2 is 23, and we just leave the denominator alone, whatever it is. So we just have to deal with the top, with the numerator, and don't do anything else. So straightforward is multiply and add. If you can do that in your head without drawing arrows, that's fine. It's just nice sometimes to see that. So 4 times 1 is 4, plus 1 is 5. Keep it over the 4. Just to make sure, I'm going to freeze it up one more time here. Play out 30, just to make sure you're good. If we're good there, we're going to be ready to actually start using the fractions for some things instead of just adjusting them constantly with this stuff and seeing how this works. So that last one there, 5 times 5 is 25. Plus 4 will get us to 29 to get that improper fraction. And again, even if it's just a couple in each section a little bit later, just to make sure it's sticking long term and that we're doing okay, that's all we're going to be looking for. So those go. So one last piece of the puzzle with these. We'll get a couple of rules on the fractions, and then I just want to help out with some again. And then we'll kind of wrap up here a little. So, fractions. Job one. If you have any mixed numbers, we've got to get them into improper first, because we need them all looking the same for this to be simple. Okay? So, improper to whole first, so 1 times 5 is 5, plus 1 is 6. We're good. If you have whole numbers, like we do here with 4, we're going to, just put it over 1, because we want everything to be a fraction. And then all you've got to do, even though I don't like the arrows I chose on here, I like looking at it more as multiply straight across the top, get the number, multiply straight across the bottom, get that number. And then as far as the simplifying goes, I'm fine. Like, for instance, if you got to 72 over 20 here and did math enter, I'm fine with you going to 18 over 5 and calling it good, okay? If you want to go to the mixed, that's okay too. It's a good skill to be able to go back and forth. But either one is showing me that you understand the concept, okay? And the only difference we're going to have between multiplying and when we get to division is going to be once we've changed any mixed numbers into improper fractions, that value that's after the division sign is just going to get flipped each time. So if it's a 1 over 8, it's 8 over 1. If it was 3 over 1, we make it 1 over 3. And so on. And so like we mentioned before, once we do that flip, it's multiply straight across. And once I do, we're perfectly fine again with either the simplified improper fraction, the 88 over 5, or dealing with its mixed number counterpart. Kind of depends on what the application is that you're using it for. So, as we take a peek at that, I'm actually, do I want to flip there? Do I want to flip here? Ooh, this is one interesting thing I just noticed. One last thing I want to do because I noticed it. I wasn't going to go here, but after what we just talked about, I think it actually might be a good idea. I just want to play quickly with one like this, just to kind of let us see. Especially since we were talking about food things. This isn't coffee and donuts, but hey, pizza's right up there too. So, 12 friends, and we'll play more with this page tomorrow. 12 friends share 4.5 pizzas. I still want to know where the other half a pizza went. Equally amongst each other. How much will each person get? Okay. So, 12 of us are dividing, 4.5 pizzas. What's that going to look like as an improper fraction? Close.
9 over 2.
9 over 2. So since we're dividing, again, we've got to flip that fraction over. So we're going to make the 12 over 1 because we want everything to be a fraction. We're going to multiply by 2 over 9. And again, once we do that flip, night. We're going to be eating some serious pizza here. That's why I'm looking and I'm like, wait. Oh! Uh-oh. Now wait a minute. Let's think about this. Hang on. Some doesn't seem kosher here. Does it make sense that each person or each friend is going to get like over 2 whole pizzas to themselves? Something don't seem right here. What happened? What did I do wrong?
Well,
Does our math work? I mean, it says we're each going to get like 2 2/3 pizza. I mean, I'm in for this, but I don't think that's right.
maybe it is right.
So if we had 12 friends and they each got 2.6, that'd be 32 pizzas. I don't. So wait a minute. I think I flipped something. What did I flip?
2 and 9.
So when I'm trying to figure out how much pizza we each get, would you agree with me that it's pizzas divided by friends, right? What did I do? Friends divided by pizzas. It's like I'm serving the friends to the pizza. That's not what I want to do. That would be kind of gross, kind of strange, some weird sci-fi movie or something. So let's fix this. My apologies. I do this every once in a while, sometimes purposefully, sometimes not. So you're like, okay, so 4.5 pizzas divided by 12 friends. I think this is going to work better. Bless you. So again, division. We're going to do us a flip. Yeah, I think this is going to become much more reasonable. Nine divided by 24. Math. Enter. Each of them are getting 3/8 or a little under half a pizza. Okay, now I think we're talking a little more reasonable. The reason I say that is sometimes we do math and we throw it in. If we get an answer, we're content. But especially with applications, take a moment and be like, does that make sense? It didn't make sense before when everybody was getting over 2 pizzas each. I'm like, I've never been to a party that's worked that way before. But this one, okay, about half, okay, that'll work out all right. So just getting you thinking a little. We're going to play more with that type tomorrow. So here's the last thing we're playing with. The practice. Heard he's switching on the fly on you here. So I think I'd mentioned this when I put it on the main slide there, and I'm just looking. So just to get some practice with the fractions here, and again, whether you go to the calculator, play with it in your head, however you want to do it, I'm very happy with, as long as we're getting the practice and making sure our answers make sense. So on pages 10 and 11, there's some multiplying with fractions. I just always will pick one side or the other. I have all the answers on the answer key for you to check as you go. So if you'd rather do evens than odds, that's fine. If you're doing them and it's going good, again, don't press yourself. You don't have to do 20. If you do like the first 8 or 10 and you're doing good, then you're good. All right? So again, when you're multiplying, just make sure you're simplifying as much as you can. So for instance, I'm going to do one with these and one with the negatives. If I challenged myself, I'm like, okay, I'm going to do the multiplying across on my own. Then if you want to try and figure out in your head what the simplest version is for a challenge, that's cool. If at that point you're like, I'm going to just see if the calculator can help reduce for me. Sometimes it'll reduce, sometimes it's not. I'll try that. So what does it mean if, let's just say I do one of these, like the one below it here. And I'm like, okay, 11 times 7, get that set. 12 times 12, get that set. and I do it, and I get the same fraction back. You know, could something have gone wrong? Not really. Sometimes they're just going to be good when you go ahead and get that part done. And the only thing I'll say is you get a little further down and you get into the negatives. Just remember the rules from yesterday. You could go back and look. A positive and a negative get you a negative. I'm going to make a little note of this. Positive, well, let's see. Let's do this. Positive times negative equals negative. But if they're the same sign, if they're both negative, that makes a positive. And we know that if it's two positive, it's positive. We don't worry about that. So do I even have to worry necessarily about putting the negatives in my calculator if I know the rules? No. I know this is going to be positive because it's negative times negative. So even if I wanted to put it directly into the calculator, not the decimal, of course, but 3 times 1 is 3. 4 times 8 is 32. Nothing divides into both 3 and 32. Well, 1 would, but nothing of any circumstance. And so with these, that's basically going to be it. Mixed numbers, we just change back into improper. We'll do one last one here, because the division we're just flipping. 32 plus 5 is 37. If you want to do it all in the calculator at once on one of these, just remember fractions you're going to want to put in parentheses if you're using the calculator. Otherwise, we can just multiply across. So the big part of today is just use the tools when you want. Use your brain. That's the best tool you have. Oops, not on the screen. But just give it a little bit of practice so as we work on some of these other things, fractions, you're feeling more comfortable with them. Okay? So again, the other one where we were converting back in the notes, we're playing with a few more of those in each section just to make sure we're good with our practice. And then this sheet on the front and back, pick you out some odds and evens, check them, make sure you're going good. And then we'll be ready to kind of jump into a little bit trickier, more part of fractions tomorrow with adding and subtracting, because there's an extra step, but nothing's